Good afternoon. My name is Sibel Schaffner. I'm the Federal Program Manager for the Advanced Sensor Instrumentation Program. And today I will provide a brief overview of my program and talk about the topics that are going to be requested under this solicitation. So the vision of the ASI program is to develop new sensors and instrumentations for monitoring and controlling nuclear reactors and fuel cycle facilities. Our goals are to provide INC capabilities needed to support the reactors and fuel cycle development, such as in-pile instrumentation for fuels and materials testing necessary to qualify them for commercial deployment. We also would like to provide new innovative measuring and control capabilities, such as sensors for harsh environments, advanced control capabilities, and fault-tolerant operations. And another goal is to help address R&D needs for successful deployment of new INC technologies in nuclear facilities, such as digital technology qualification to help us move from analog to digital, advanced operational concepts, and focus on demonstration to provide science-level evidence for regulatory acceptance. All of this goal will support our new GAIN initiative. If you're interested in seeing what type of research we do and we have funded in the past, we have our annual summary available in our website, and also we issue semi-annually newsletters which have articles and information on the program. So our program is divided in 4 areas. The first area is advanced sensors to develop a fundamental understanding of sensors performance and to improve physical measurement accuracy and reduce uncertainty. The second area is digital monitoring and control to provide increases in control systems performance and self-calibration capabilities. Our third area is nuclear PAN communication. We're looking for advanced communication technologies that support greater data generation and transmission demands while maintaining reliability, resilience, and data security. And the last area is advanced concept of operation to develop and test higher integral control system architectures where new human and system interaction is defined. Research in these areas are needed to support at least two or more of the programs listed on the right side. And we check with them on their priorities, and they're still, these areas are still valid. For this solicitation, as I mentioned before, we're going to be focusing on the advanced sensor. This slide provides the overall goal and objective for all the subtopics that, under my area that we'll cover today. The focus is advanced sensor instrumentation that can operate in a nuclear facility. So to be responsive, you need to address the objective listed here. You should show us how your technology is better, more accurate resolution, the current technology, and how it is designed to fit in the target nuclear environment. Second, you need to demonstrate how much better measurements it can provide and what the measurement uncertainty is and how it will perform in an intended nuclear environment. And third, since this is a cross-cutting program, we will be looking for proposals that show research that can benefit multiple reactors and fuel cycle applications. And also, please tell us how your technology will support the new GAIN initiative. If any of these are not applicable for your proposal, please address them by providing an explanation of why not. So for the first topic, we're looking for sensors that are embedded or integrated in components or functional materials. The goal here is to improve system performance by removing control loops that add data transmission process and actuation time to current process control approaches in monitoring and controlling a component or system. So successful research will demonstrate improved performance and reliability will provide testing and demonstration of the integrated system, including a description of system metrics, and will provide anticipated system performance improvement. So that's topic 1. The second topic is looking for proposals for 3D sensor networks for monitoring passive structural systems. We're interested in the ability to measure and characterize the behavior of critical materials such as concrete, metals, cable insulation, and other critical materials to nuclear energy applications. And we want to do this in service, over time, and as a network. In service, to understand how the target environment conditions affect the measurements. Over time, to understand how changes in the material over time affect the measurements. Consider how to use the data generated by a sensor network and apply it to monitoring of the material over time. For example, are there materials being subject to stresses that may cause the materials to degrade more rapidly than estimated when placed in service? At what rates and subject to what effects in the service environment? And how do these measurements results relate to the margin of material capability or the remaining useful service life? And as a network, using more than one sensor to understand the whole behavior of the material and not just a sample. We would like research to identify the optimal number of sensors for different materials monitoring applications. We're interested in the results of monitoring from a network of sensors to help provide confidence in the measurement and characterization, as well as to reduce reliance on statistical inference from limited sampling. So for the third topic, we're looking for advanced sensors and instrumentation specifically designed for treat, including remote techniques applications for transient experiments. Successful design needs to be qualified for deployment in the treat reactor in support of the transient testing of nuclear fuel samples. The challenge here is to figure out how to use high-fidelity instruments in the location of interest without disturbing the condition of the test fuel pin, and to do it remotely in a hot cell. The key challenge is working on a pre-irradiated fuel and assembling the experiment inside the hot cell with a telemanipulator. The ability to do that is usually more limited than the existence of a specific sensor. For example, strain gauges have been around forever, but they have never been used in transient testing because there hasn't been a technique developed to apply them to the specimen remotely. So, and for more information on the TREAT program and instrumentation needs, please contact Dan Wax at INL, and he'll be available at the end to answer any questions. Okay, now switching areas in the solicitation under the Nuclear Science User Facilities, NSUF 1, work scopes. All applications accepted will be for projects coupling R&D with NSUF access. So note the development must be at the irradiation testing stage. This is not for preliminary development R&D. All materials and samples must be available at the time of full application submittal, so that they're available about 5 months after the project initiation. So you can find more information on the NSUF portion of the solicitation. So for our area, we have 2 topics. The first one listed here is looking for proposals that use advanced manufacturing techniques to develop new sensors that can be qualified and applied for measurement and characterization of fuels and materials behavior during in-pile irradiation. Here we're looking for precision manufacturing on the small scale, similar to semiconductors and other micro nanostructural material manufacturing enterprises. We're interested in sensors on the small scale that can be developed and manufactured that could be, for example, directly attached to the material of interest, like the fuel or the piping or the reactor pressure vessel, etc. in many locations instead of just one, with few size constraints. They would also, because of their size, not interfere with the phenomena of interest. This workshop offers the opportunity to test and demonstrate the performance of these new sensors and manufacturing technique designs. Please tell us how these sensors will be applicable to an in-pile application or an irradiation test program or any plans for deployment. The second topic listed here is looking for proposals in two areas that support development of advanced materials for sensors and for development of advanced sensors themselves through in-pile testing and post-irradiation examinations. So for advanced materials for sensors, there's an opportunity to test any materials that are proposed for advanced sensors for survivability and performance in nuclear environment. Please provide a description of the materials, what irradiation, post-irradiation needs you have, and how these materials will benefit new sensors and applications. In the advanced sensors part, there's an opportunity to test these advanced sensors and associated instrumentation for nuclear energy applications. Again, please provide a description of the sensor, what irradiation, post-irradiation are needed, and the purpose and application of this particular sensor. See, again, this is an opportunity to further advance the development of materials and sensors and test them in a radiation environment. I want to note that if you have already developed a material or a sensor that is ready for testing and no further research is needed, you can also apply under the NSUF 2 topic, which provides access only. This topic was presented yesterday by Rory Kennedy, and it includes instrumentation as one of the areas. So you can look into the FOA under the NSUF 2 section for more details and information. So in summary, these are some of the expectations for this FOA. As you plan your proposal, I want to stress out that we are looking for advanced INC technologies that will support reactors and fuel cycle development and deployment. We're looking for improved economics and safety. We want to see demonstration of the proposed technologies in a setting that represents the nuclear power industry. And we're looking for innovative and revolutionary cross-cutting technology that supports multiple reactor designs and fuel cycle concepts and supports the GAIN initiative. Bruce Halbert from the Idaho National Laboratory is my technical lead for this program, and he will be online to help answer technical questions. So with that, thank you, and I'm ready for questions.
Bruce, are you there?
Yeah, this is Dan. I'm here.
Yep. Yeah, I hear both of you. Okay. Does NEET 2.1 or 2.2 cover instrumented casks?
2.1, is that the, hold on a second, let me go back, I didn't, I don't think we covered casks in particularly. I will defer that to Bruce. I don't think it's the case, but Bruce, do you have any opinion?
No, we didn't talk about casks specifically, but in the first call area, you know, we left the call area pretty broad, where we're looking for innovative proposals for nuclear energy applications. So it's open. You could apply for casks as well in that area.
What is the exact definition of 3D sensor network? I'm curious as to what 3D means in this context.
We would entertain a proposal in there. It would depend upon, you know, how cross-cutting it were. If we saw its relevance to, multiple reactor concepts or, multiple reactor types, long term, then yeah, I think we would be interested in that. Of course, we'd have to see the context of the proposal. And then, of course, we would talk with the relevant program managers in the different reactor concept development areas and see how that would scale for what they're interested in, and see how NEET can support those programs through that particular application. So I would say it's worth at least a pre-application as long as you can tie it to the goals of the program.
In NEET 2.2, is there interest in 3D radiation monitoring networks for these materials, limited to in-core or ex-core?
I'm not sure if we're looking for radiation monitoring. It depends, because we're trying to figure out measurements and how materials change, so I don't know if they're targeting radiation, but I guess it will depend how it's proposed.
Yeah, I think we were looking for sensors and suites of sensors that would interrogate the condition of the material more directly.
Yeah.
Looking at radiation, of course, is a precursor to understanding how the material changes as a result of radiation exposure, perhaps. I may be reading more into that question than I should, but so I would agree with what Sue Bell says. It depends upon why they're proposing it and what sense it makes in the context of the proposal. But again, if it's tied to that call area related to 3D sensor network for monitoring of structural materials, we're interested first and foremost in structural materials. So you have to make the case for what your sensor network does and why the things you're measuring are of relevance to that application.
How many awards are expected under NEET 2?
I think we're going to try to put 3 awards, 1 for each area. At least that's the target right now, but it will all depend how much funding we get in appropriation.
How is the monitoring of passive components called differ from the work being conducted at Vanderbilt University?
I'm not aware of all the work that's being done at Vanderbilt University. I'm aware of some work that is being done at Vanderbilt University in support of some research through the LWRS program. And that work is in support of studying alkali silica reactions specifically in concrete. So that's a very specific topic. What we're interested in here could be applied to many types of structural components in nuclear energy systems, from containment structures, steel structures, piping, could be applied to many different types of structures. We're not, we're certainly not limiting it to one particular phenomena.
Does the interpretation of the input from the 3D sensor network, is that required to be included in Moose or Grizzly software? Or is it even preferable?
I don't think at this time that I don't think it's necessary to relate the signals, especially the signals coming back from the 3D sensor network into a Moose or Grizzly model. I think it's important to have a good physics model of the structures and systems that you're monitoring, and maybe you would use whatever system for modeling that. And if you prefer to use Moose and Grizzly for that, that's fine. I wouldn't get into the discussion of what types of codes are most appropriate for that, but so no, I don't think there was an explicit consideration of tying this to Moose Grizzly.
Will the 3D sensor network include multimodality sensors or a single type of sensor?
It could include either or both.
Is materials aging modeling to better interpret data from sensors applicable to NEET 1.2 or NEET 2.1?
I'm not sure.
Not necessarily. I don't think that we were interested in only materials aging. I mean, there can be a number of things that you monitor materials for, including their performance in situ. And aging is just one factor. You can also look at thermal cycling of materials. You can look at various other things that different components in a nuclear energy system go through and monitor. Piping systems go through a variety of different things that are service-induced as opposed to necessarily aging-induced, unless you lump everything under aging. So I don't know. It depends upon what you consider aging, and it also depends upon what you choose to include in your model.
For NEET 2.3, do we need to implement the sensors in the treat reactor?
I think that's clearly the ultimate goal. I think if the scope of the project is such that you can reach that point by the end of the project and do a demonstration there, I certainly would encourage that. If it's a less mature technology or concept that is at the beginning and low TRL levels, that it's not realistic to do deployment in a 3-year window, then that's reasonable as well. But I think that you would want to talk about the trajectory towards getting it to that point, and what would be necessary after the completion of the project in order to fully evaluate it. But I think that's clearly our objective, is we want to see things that have a harvest strategy and a deployment plan.
Is wireless communication and power harvesting of interest to this call?
Usually that's in the communication area, but if we can tie it to one of the topics that we talk about it, yes.
Are LWR sensors being investigated under this FOA, or just advanced reactor working fluids and structures?
It's a cross-cutting area, so we try to fund research that applies to multiple areas. So if we can make a case for LWRS and also that applies to advanced reactors, that will be applicable.